Good morning. My name is Dario Trabucco. I'm the CTBUH research manager, and I work in the CTBUH office, research office based in Venice, Italy. I'm going to present you the result of a research project that we conducted in the past 12 months. Thanks to a research grant that the CTBUH received from ArcelorMittal on a topic that I thought at the beginning was quite boring, but it's not. It's measuring the floor area of tall buildings. It's an industry need. Before we get into the details of this, I just wanted to, can you please, whoever is cold in here, can you raise your hand? Okay, so we're spending energy to do something that makes people uncomfortable. How many of you had problems in the past few days with the elevators in this building? Again, probably more than 50%. We'll get to know why this is relevant to the topic of my presentation. So, as I was mentioning, this is a research project, so I was directly involved into this project in the past 10, 12 months probably, together with my colleague in Venice, William Miranda. And the project was sponsored by ArcelorMittal that has, we will see this, quite some reason to be affected by this problem, by the problem of how to measure the floor area in buildings in general and in tall buildings in particular. So the objective of the whole project was the identification of the existing codes that are used to measure tall buildings area and likely with the ultimate objective to create a new code or something that is accepted by the industry in the tall building industry that is accurate, precise, and reliable. So the problem of measuring something at the beginning, I thought it was quite simple. You ask your five years old daughter or son to measure the floor of this room. You take a tape and you measure from one side to the other, and this is it, right? I mean, it seems to be a pretty straightforward task. Unfortunately, though, when you start to look at this from a professional point of view, it is not that simple and it's not that straightforward. And actually, there are so many definitions that have to be taken into account and that make sense in some industries. So that's the gross floor area, the net internal area, the net rentable area, the carpet area, the gross internal areas, and so on. But whenever we talk about measuring buildings, we also speak about having the possibility to compare buildings across markets and across countries and to have data on them. So whenever we say this building has a maximum occupancy of 1,300 people, and that was the cap that we had for the conference, is because according to the floor area, to the space available for these 1,300 people, we cannot have more or it will be dangerous. The air conditioning here is probably sized the wrong way because the number that the MEP experts had available was not that correct. And the same thing happens with the elevators, and the same thing happens with I'm usually work on the sustainability. When you have to assess the sustainability of something, you're looking for the energy consumption per square meter or per square foot of that building. The problem is that if the way you measure the square foot in this building is different from the way you measure the square foot somewhere else, the resulting number doesn't make sense anymore. So unfortunately, every market, and even within the same country and the same market, there are multiple standards that are accepted to measure the floor area of buildings. And even the same definition of GIA, NRA, and carpet area, and so on, vary quite significantly from country to country and from market to market. So if you're measuring the gross floor area of a residential building in New York is different from the gross floor area of an office building in New York. And the discrepancies are quite massive. So there are buildings that have been sold in 2010. I'm talking about a case in New York with a certain area. After a few years, the building was sold again, and it was 42% bigger without any construction work happening on the site. Just because a different measurement system and a different professional were involved into measuring the floor area of the building. And from a market to a different market, the variations are so huge that you can get to 24%. So build two exactly identical buildings in New York and in China or in London or in Dubai can have a 24% difference just because they are measured in two different ways. Because every country or every industry within a country use different codes. So we have here an example. BOMA is an accepted standard since over 100 years in New York that then expanded internationally. Is now starting to be used quite consistently in Australia, in South Africa for office buildings, but not for residential buildings and retail buildings. And then we have the Royal Institute of Chartered Surveyors that also created their own standard for the UK, but then they were able to make this standard used and accepted also in other markets, including, again, Australia, New Zealand, Canada, and so on. The problem is that buildings are real estate values that more and more often, especially tall buildings, are negotiated by international organizations. So developers from China build buildings in New York, in London. Dubai acquires building in Europe. American funds support the construction of buildings in Australia. It's marketing, it's business. This is the reason why we're here, right? But the problem is that when you want to know if your 100 millions are more worth to be invested in China or in Australia or in New Zealand, and you cannot compare the result of your investment in terms of square meter, in terms of what possibility to host offices, or in terms to understand what was the cost of this building, because you cannot divide them by a uniform and homogeneous measurement system, then you cannot really create business. So the way buildings are measured also influences the way buildings are designed. And there are multiple examples in Hong Kong, in Singapore, where the local policies of measuring building were changed to produce positive effects in the built environment. And there are so many other examples of policies that actually created a negative impact on the way buildings are designed. For instance, the fact that in Hong Kong and in Singapore, terraces for a certain amount of time and balconies for a certain amount of time were not measured, were not part of the area that you were allowed to build. This resulted in the fact that the buildings started to have terraces and balconies, because if you're allowed to build 100 square meter, but the terrace is not included in this measurement, it means that you can build the 100 square meters plus a balcony and sell that balcony as part of the value of the interior space. If your 100 square meters include the terrace, then the house that you can build is a little bit smaller and you cannot sell that extra space. So it's a way that the way that we write codes and we influence the market also influence the way buildings are built and the way the life that's happening in these buildings happen. So to try to sort out this problem, about 5 years ago in 2013, the World Bank, the World Bank, not an association, not a building industry member, not someone who's doing measurement activities, but someone who's putting capital and investment, decided that there was the need for an internationally accepted standard, and created this IPMS organization that stands for International Property Measurement Standard Coalition. CTBUH last year became a member of this because, of course, we're interested in measuring the height of buildings. Actually, the CTBUH is the one address where you have to go if you want to measure how tall your building is, actually to have the criteria on how to measure the building. And we also want to have a say on how the area of building, the surface of the buildings is measured. So we became part of this association that includes profit and non-profit organizations from literally all around the world to have to contribute and to give the tall building perspective advice on how to measure buildings. The panel that has to create the standard is formed at the moment by 18 experts, again representing different countries, different cultures, and different industries. And it meets once a year for 5 days, a 5-day meeting locked in a room to understand and to decide what is the evolution of the standard. After a standard is created, it goes through 2 stages of public consultation, so to make sure that it is accepted at least by the industry and all the different aspects are taken into account. And at the moment, we are in the second phase of the public consultation for retail offices, retail buildings. So we started in 2014 with office buildings, now residential, industrial buildings, and now retail. How these standard that prescribed to measure buildings, we decided to get rid of the usual definition of net rentable gross floor, because in each country they mean something different. So we started with IPMS 1, 2, and 3 that broadly represent the total area, including the exterior, the internal area, and IPMS 3, a subdivision of this. So IPMS is usually the bigger number that you can, IPMS 1 is usually the bigger number that you can get when you measure a building. IPMS 2 is the area that is inside the external perimeter of the building, so what you will call gross internal area, even if this is varying from country to country. And then there is the IPMS 3 that is more likely to correspond to what you would define net internal area. And then, of course, there are instructions on how to measure each single component within a building. The problem, however, is that the current way that IPMS measure IPMS 2 and 3, so the internal space of the buildings, relies on a concept, an idea that is very well accepted in the countries where BOMA sets the rules, so largely in North America, but also in New Zealand and Australia and South Africa, which is something that is, I think, acceptable in a normal building, but it becomes very, very tricky when you have to deal with tall buildings. The reason why is the concept of internal dominant face. So internal dominant face is measured when you measure something to the internal dominant face. You measure it to the inside finished surface that makes up more than 50% of a section of the wall, which means that if you have a window that is bigger than 50% of the area, then you go inside to the glass pane. If you have a window that is smaller than 50%, then you go straight on the wall. Where is the problem with tall buildings? It's here. Columns are not considered. So if you have a column, no matter how big the column is, you simply go through it and it doesn't exist. And why this is a problem in tall buildings? Because we're seeing more and more of this. So this is a tower actually under construction in China. This is the Suzhou Center. And it has 12 columns that are larger than a fire escape. 12 columns. This is 400 square meter per floor multiplied 142 stories. That's a hell of a lot of space that doesn't exist, but is calculated. And so the MEP system is designed considering that that floor is occupied by people sitting here. The elevator guys calculate the vertical transportation demand of the elevator according to the people that is going to dance in this column. And all the services are designed considering that that column is like this unit. This column is this unit, no difference. This is a tall building specific requirement because this is something that doesn't happen in the majority of the buildings that you'll see around the world. As a designer also, I say that this doesn't reflect quality design because this building, I think it's a concrete building, very likely, but it means that my capacity as a designer to design a more efficient structure that requires different number of columns or smaller columns or maybe more columns but placed in a different position, it's not recognized because the column simply is not there. So the evolution of IPMS is actually, as I was mentioning before, we are at the moment where all the 4 standards that represent the vast majority of buildings, so offices, residential, retail, and production buildings, is about to be completed. So this process is about to be finished. But the way that the IPMS worked is that the most recent document, in this case, the retail one, is the most accurate because we gained expertise in writing the code. We gained expertise in receiving the feedback from the industry. So the code that was written, the office code that was written in 2014, doesn't reflect the most accurate definition and the result of all the conversations that happened since then. So we decided to start over. And the IPMS codes will be literally rewritten rather than just harmonizing these 4 different codes. We'll start over and we'll have one single standard, one single IPMS document that applies, that can be applied to all the 4 building types. This will include again IPMS 1. Which will remain pretty much the same because this is the biggest measurement information that you can have. It will maintain IPMS 2 because we acknowledge that some markets have been working this way for the past 120 years. So it's really, really difficult to to force this market to get rid of the way they used to do things. But there will be a new definition of IPMS 3 and a new IPMS 4 measurement system. And these 2 last systems will be the actual area where you can put things, where you can put your feet, where you can actually do the things that the building was designed to build. We always have to remind that buildings are built for people. And if you cannot go somewhere in the building because there's a column, because there's a double skin facade, because there's something else that is not usable space, that's not something that you can really appreciate and pay for. So as I was mentioning before, this new IPMS 4 will take into account not only the presence of columns, but also the presence of other elements that can somehow prevent a complete freedom in the use of the space. This will go through the adoption of the internal finished surface. So all the measurement in IPMS 3 and the new IPMS 4 will likely, I'm talking about something that has not been written yet, so that's the CTBUH commitment for the next phases, will go to the actual finished surface of the walls. That's including columns, that's including double skin facade, that's including everything that is not part of the space that the tenant of an office or the occupant of a residential space can really use. Again, creating this difference between internal dominant face and internal finished surface that goes around the column and then takes into account of those 400 square meter of publication. The nice thing of IPMS is that it's an international organization, it's a non-profit organization set for by the World Bank, as I was mentioning before, and thus the way IPMS suggests to use when you measure a building are actually being implemented by the local registration. So IPMS 1 is the one measurement system that you are advised to use in Dubai. It's starting to be recognized also in Australia. The Royal Institute of Chartered Surveyor has to take the definition of IPMS into account when designing the other standards. So it will be implemented also by other industries, and then and thus will hopefully very soon, even though we may acknowledge that this process can take several years, we'll get to the point where you can actually measure in a consistent and reliable way the surface of a building, and you will be able to design buildings taking into account a more straightforward and acceptable methodology to understand how big buildings are, and have the possibility not just to compare one building against the others in terms of energy measurement or in terms of cost per square meter or in terms of whatever other parameter may be divided by the surface, but also to make a judgment where a building makes a more efficient use of the space. Very likely CTBUH in the next years, so when the code will finally be written and available to the public, will start to use IPMS 1 to describe the general volume of the building, multiplying the surface by the height you obtain the volume, and IPMS 4 as a measurement of the space that you can actually use for the purposes that the building was meant to be. Thank you.